A ball with an initial velocity, so that's v0, of 25 meters per second is subject to an acceleration of negative 9.8 meters per second squared. So what's happening here is you throw a ball up in the air, well actually it'd probably go a lot straighter than that, and the whole time it has an acceleration in the down direction, and we call that negative 9.8 meters per second squared due to gravity. We want to find this distance here, delta x, how high it goes before it comes to a momentary stop, at which point it then starts coming down. So when we have our equation, v squared, third kinematics equation, plus 2a delta x, this is the term we're trying to solve for. We know a. We're going to say our final velocity in this case is 0 because it's at a momentary stop. So let's go ahead and solve for delta x. And let's see if we can do it all in one step. We know we have to put v0 squared on the other side, so that makes it a negative. And no matter what v0 is equal to, negative of v0 squared will always be negative. You take this negative in after you square the v0. In this case it doesn't matter because v0 is positive. And we divide it through by 2a. Now this may concern you a little bit because this looks like we'll get a negative number, which we know isn't the case because we're throwing it up, which is a positive direction. But let's see what happens when we substitute in the numbers for the variables. Well, here we have delta x is v squared minus v0 squared divided by 2a. We already got rid of the v squared there. So you have 0 minus 25 meters per second squared divided by 2 times a negative 9.8. So that's where our negatives cancel out. The negative here in a cancels with this negative, and we get a height of 31.9 meters.